is Ukchan Shin.
I'm Michelle Frisbee.
I'm Kenton Anderson.
I'm James Grau.
And today we are here to present DP2 regarding BRG project. First, let me briefly introduce what we are going to present today. Here is our mapping slide. Next slide, please. So, the project management update reports that the team finished the prototyping and other planned tasks. And we have also come up with intellectual property with a variety of patents. Product decomposition and concept selection will be demonstrating sub-problems with ideas for obstacles. The FMEA analyzes the unit conversion obstacle. And lastly, an economic analysis finds the need for investment concerning final BRG project. And further information will be presented by other team members.
So we've updated the Gantt chart since the last report, and we're still on track with what we scheduled. Although we did make an adjustment, we could change the intellectual property to be parallel with our prototyping. So that helped because we also had to extend the time of prototyping because it took longer than we predicted. And we're currently still on track to finish by November 30th. And then from this design structure matrix, you can see the dependencies of all of the tasks from the Gantt chart, and from here you can see the two tasks that are now parallel.
We did a good amount of comparing our project to a few similar patents that are already out there. And the main thing we noticed with other patents is that they took a main focus on either educational values or entertainment values. And with our project, the one main advantage we think we have over the market is that we do a good job of combining both. A few notes we took from other patents that we witnessed is that a big selling point seemed to be one, that the games were portable, also that they could incorporate multiple players at a time, and lastly, it's just their advertising with being physically appealing. And so those are all main things that we're trying to incorporate into our project, and we're thinking about, like I said, adding extra players, making it lighter weight, and making it cheaper especially. Our price is significantly higher than any of the other things on the market, and we think this is one of the main things that may hurt the sales of our product.
Product decomposition breaks down the problem into sub-problems with the motor and other aspects of the obstacles. Those black boxes indicate the flow of energy, the movement of the ball, and the signal when the Arduino motor will be triggered. Next slide, please. So this figure is the diagram of all the sub-functions of the FCL machine organized with the obstacles. The black boxes diagrams are significant to recognize how the energy flows through a product and applied on the object to successfully overcome each obstacle.
During the concept generation phase, we each came up with different ideas for the three categories of learning we had, which were unit conversions, volume, and conductivity. And then we came up with a series of different combinations with one from each category. And then here's just an example of one of our combinations. And this combined the diameter conversions, the volume of a cube, and conductivity with a conveyor belt. And then from the five concept solutions we came up with, we used a scoring matrix. So a plus meant it was above average, a 0 average, and a minus below average. And then this axis here has the criteria we graded it on, and then of course the solutions across the top. So then the scores for each were added up, and if the net score was below 0, it was eliminated from the possible solutions. We also had a concept scoring table, which it still has the criteria we graded it on at the side and the possible solutions at the top. And then we gave a weight to each of the criteria and a rating, and by multiplying the weight and the rating, we got the weighted scale, and by adding them up we found the best solution based on our criteria, and our solution was the first one, which was the combination I showed on a previous slide.
By surveying 6 potential candidates, we were able to collect some data for concept testing. In the figure, you can see some numbers we used to get a rough estimate of a quantity of units we could sell, potentially. The quantity is based off the number of adults who would like to buy the product. Through the survey, we were able to see that children really were not that interested in the product necessarily. And it came out that 187,500 units were potential to be sold to adults.
So we ran a failure modes and effect analysis on the first obstacle in our project, and there were a few different areas we found that it could fail in, but the most prevalent was at the conveyor belt. Each one seemed to rank pretty similar in severity, and the consequences were all about the same. The ball would just not continue through the obstacle course. But again, the most likely to happen one, and you can see its RPN value is about triple the value of the other ones, was for the conveyor belt to fail. And we believe this is because there's a few different things that could cause it to fail as the product ages. The conveyor belt could get a little bit more resistance, as well as the motors on the conveyor belt could die down a bit, and either of these could cause the ball not to go to the top. There was one last thing we considered, and that's the ball may end up somehow getting stuck in the conveyor belt and not being released at the top. But for the most part, we aren't going to consider that as much, just because it's much less likely to happen. And some improvements we might make is just simply buying more expensive or longer lasting motors for the belt, or even just getting ones that are much stronger than we really need, so that in the future when they do die down a little bit, they'll still be able to push that belt and get that ball to the top of the project.
It was decided that we would need a loan of $500,000 and one lump sum at the beginning of the project. This calculation was based off our needed manufacturing cost, our startup cost, as well as the cost we would need to pay our employees. And it would be paid back at an 11% yearly interest rate by the quarter. Starting after the first year the loan was given to us. And so it'd be able to be paid back in 8 months at a rate of $78,557.40 per quarter.
In conclusion, we are pretty up to date with our Gantt chart, and we are sticking to schedule about as planned. We're even a few days ahead of schedule. So far in our project, we've selected the concepts that we're going to do, and we've even prototyped all 3 obstacles that we've decided on. From our economic analysis, we've decided that we expect to sell 187,000 units, and we're expecting a loan of $500,000 to be paid back at 11% yearly interest rate. As far as our plans for the future, we've decided on a few potential improvements we could make as far as the materials, making it cheaper, incorporating sales, making it more visually appealing.